Welcome to qnawire.
Okay, in this question, we have two wheels connected by a string attached at the top of the wheels. The wheel on the right is moving with the center of mass velocity of 0.4 meters per second. Its point C1 is touching the ground at C1. Its radius is 0.15 meters. The other wheel is made up of two cylinders, a larger cylinder with radius 0.2 meters, and a smaller cylinder with radius 0.1 meter. And that smaller cylinder is the one that's touching the ground here at point C2. And we want to figure out how fast point D is moving. So to do that, we can take a look at a couple of things here. We can calculate the velocity of point A. We find the velocity of point A just by looking only at the right wheel here. We know that the velocity of A divided by the length AC1 has to equal the velocity at point C divided by the length of CC1. Since AC1 is twice the length of CC1, that implies then that the velocity of A is twice the velocity of C, or just 0.8 meters per second, which you can just get just from the algebra right here. CC1 is just the radius, and AC1 is twice the radius then. So we know then that VB is attached to B is attached to A by a string, so VB must equal VA. So both of those are 0.8 meters per second then. We can calculate the angular velocity of point B. And that angular velocity will just equal the velocity of B divided by the length BC2. We know the velocity of B. BC2 will just be the radius of the larger. Let me draw that a little bit clearer. The radius of the larger cylinder plus the radius of the smaller cylinder, which will be a total of 0.3 meters then. So this gives us an omega of 8/3 radians per second, or if you do not like fractions, that's about 2.67 radians per second. So we figured out what omega is. We still need to learn then what this distance C2D is, and we can get that by looking at this right triangle here, C2OD. So we can find that C2D or DC2, whichever way you feel like writing it, is just going to be the square root of OC2 squared plus OD squared. OC2 is just 0.1, OD is 0.2, since those are just the radii of the two cylinders. We put those numbers in and we get about 0.2236 meters for our length C2D. We can then find our velocity of D by looking at omega times C2D. We found omega below is 2.67 radians per second. We found C2D as that 0.2236 meters. And this gives us the velocity of point D as 0.596 meters per second. And just to note really quick here that if nothing changes in this case, this means Well, we have to look at which direction D is moving, and D will be moving down to the right, kind of like that.